So, you spoke about the EMP Commission, but I know that a lot of the different companies that make devices are also offering these devices and installing these devices on first responder, municipal, state, and government agencies for their vehicles, because obviously they need to stay mobile and able to do their job still. And so, can you talk about some of the testing that's involved in order to make sure that these devices are up to snuff for these
Sure.
regulations or licenses or whatever that needs to be?
Yeah, no, it's a great question, and so I'll give you a corollary. When we field satellites in NASA, right? We build the satellites with lots of ideas in mind of how it's going to survive different events, and then we take them into electromagnetic chambers, and we run a series of tests on them. Mil standard 461 tests, pulse tests, all kinds of tests on them, right? And then we're confident that under those environments, this thing will operate, right? And then we fly it. And so many satellites would survive an EMP. It's part of 461 testing now, right? And so we go to that expense in NASA. In the space industry, that cost is so small compared to the cost of putting something into space or developing something. Of course you do it. With cars, though, or any other small-scale electronics, it's very expensive to test, and there's a lot of misunderstanding about what is being tested. All right, so let's just give you an example. Let's say I've got this DEF CON, right, and it's a heavy-duty, like really nice product. If I take that and I test it versus an EMP, I am 100.0% sure it would survive. Okay, how am I sure? Well, an EMP can't introduce enough energy to damage all those transient parts in there. There's no possibility it could. I am 100% sure, though, that this one would survive an EMP. I am 100% sure that this would survive an EMP. I'm 100% sure, not even slightly unsure. In fact, I'm 100% sure that many things that don't have complex electronics would survive, let alone anything designed to turn on at high voltages, right? But it doesn't prove anything. Just because my DEF CON survives doesn't mean your car is going to survive, right? I'm not testing your car. Now, if I run a test on this product and I say it's EMP tested and it survives, the value of that is small, okay? There's not a lot of value of that because you should expect that, okay? If it didn't survive, we built a bad product, okay? The bigger question is, if I hook that to my car and I take my car into the EMP chamber, will my car survive? Right now, if I show that, all good. Okay, now I've accomplished the mission and the goal, with just like the satellite. We take the satellite into the room, right? And that is very expensive and just not done, frankly. The EMP Commission did a little bit of that, but what they did is even they were worried about the cost of damage to the cars. So they only dialed up the pulse until they started seeing anomalies, and they said, "Whoa, dial it back down. That one's going to have susceptibility." They didn't go hit it full scale. Let's see if it breaks, all right? Because they didn't want to damage a bunch of cars. So what I tell people is, yes, it's good to have things tested to mil standards. Individual products, mil standard 461 or 464 or 2882. Sure, you can do it. 18125-1. You can test them, and you can be confident that somebody didn't do something stupid and put like a really sensitive piece of equipment in there. But it does not guarantee that your product will be protected, okay? So what you really want to do is see real-world tests of this thing attached to something, and then that something tested, okay? I hope we get there, all right? It's just such an expensive process, people don't do it right now. Now, I'm very fortunate. I may have a way soon to at least do small-scale testing of true EMP energy on devices, not just protective devices, but full-up systems. And that would be great, because it'd be nice to have some videos of, hey, we're going to put this laptop in here, and we're going to attach this protective system, and bang, we hit it with an EMP, and it's still working just fine, right? That tells me something. Now, there has been some of that done, to be fair. The only company I know who ever did it is a company that makes solar energy inverters and solar energy systems. Everybody would know them if they search EMP solar, they'll find them. They actually bought their own EMP generation system, is my understanding, and they started zapping their systems to find out where they broke. And indeed they found, whoop, this broke, we got to add more ferrites here, we got to do this here, and they could get systems that would survive an EMP. So that, hats off, right, to that. That's great. But other people who market things as EMP products who have been tested, they're really just testing their products. So be sure you understand that when you buy them. It's not a negative, but it's not the full up, all is good. Okay, so they need to take that one step further. The perfect test, of course, would be I take a vehicle, I roll it into the chamber, I zap it with an EMP, and it is damaged. I slide it back out, I replace the defective components, I attach protective devices, I roll it back in the thing, I zap it with an EMP, and it is not damaged. Same vehicle, all I've done is add the protection. Then you could be confident, my protection really does save my car, right? But you can imagine...
Just that particular car.
Just that particular car, right. And you can imagine, well, yeah, but that's a Ford F-150. I've got a Chevrolet whatever, right? And so maybe they're not quite the same. And you can understand the complexities and difficulty of that. But all that aside, tested products are better than non-tested in terms of just having data, so I'm good for that. And we should just look to advance the testing further, where we can start demonstrating systems or at least subsystems that show that you've protected them. All right, that's my pitch on it.